Updating the risk-based inspection (RBI) assessment, enhancing inspection processes for improved risk management. Overview of updating the RBI assessment, why RBI must be updated, evergreening and reassessment concepts, evergreening the RBI assessment, typical evergreening activities, understanding RBI reassessment, triggers for RBI reassessment, impact of process and hardware changes, additional drivers for reassessment, when to conduct RBI reassessment, role of risk mitigation strategies, keys to success in updating RBI. Risk-based inspection, RBI, is not a static or one-time analytical exercise, it is a dynamic risk management tool that must evolve alongside changes in operating conditions, inspection findings, and organizational knowledge. The primary purpose of updating an RBI assessment is to ensure that inspection plans, mitigation strategies, and risk rankings remain aligned with the current condition of equipment and the realities of plant operation. At the time an RBI assessment is first performed, it reflects the best available data, assumptions, and understanding of damage mechanisms and consequences. However, as time progresses, new information becomes available through inspections, repairs, process changes, and operational experience. If this information is not systematically incorporated, the RBI program can quickly become outdated and lose its effectiveness as a decision-making tool. Updating the RBI assessment ensures that changes such as inspection results, equipment modifications, maintenance practices, and mitigation strategies are properly reflected in the calculated risk. This enables owner-operators to prioritize inspection and maintenance resources where they are most needed, improving safety, reliability, and cost efficiency. An up-to-date RBI assessment also supports regulatory compliance and alignment with industry codes and standards, which increasingly emphasize continuous risk management rather than periodic, isolated reviews. From a management perspective, updating RBI strengthens confidence in inspection intervals and methods by ensuring they are justified using current risk profiles rather than historical assumptions. It also supports proactive identification of emerging risks, such as new or accelerated damage mechanisms caused by subtle changes in operating conditions. Ultimately, maintaining a current RBI assessment helps organizations prevent unexpected failures, optimize inspection scope, and demonstrate due diligence in managing asset integrity across the lifecycle of equipment. The fundamental reason RBI must be updated is that risk itself changes over time. Risk is a function of both the probability of failure, POF, and the consequence of failure, COF, and both elements are influenced by evolving operational, mechanical, and environmental factors. As equipment ages, degradation mechanisms may accelerate or change in nature. Inspection activities can reveal actual damage rates that differ from original assumptions, while maintenance and repair actions can reduce risk by restoring equipment condition or eliminating specific damage mechanisms. Operational changes such as adjustments to temperature, pressure, flow rate, or process chemistry can significantly influence corrosion rates, cracking susceptibility, and overall equipment integrity. Even minor deviations from intended operating windows, if sustained, may invalidate earlier RBI assumptions. In parallel, consequence-related factors such as population density, production value, environmental sensitivity, or regulatory expectations may also change, altering the impact of a potential failure. If RBI assessments are not updated to reflect these realities, inspection plans may become misaligned, either over-inspecting low-risk equipment or, more critically, under-inspecting high-risk assets. This can result in inefficient use of resources, increased likelihood of unplanned failures, and reduced confidence in the RBI program. Regular updates ensure that RBI remains a living system that supports informed decision-making, continuous improvement, and alignment between asset integrity management and business objectives. When updating an RBI assessment, two distinct but complementary concepts are used: evergreening and reassessment. Evergreening refers to the continuous, incremental updating of RBI data and results as new information becomes available. It is typically performed at the asset or component level and focuses on incorporating inspection results, minor process changes, equipment replacements, or repairs. Evergreening ensures that the RBI database reflects the most recent condition and operating context of individual equipment items without revisiting the entire assessment scope. RBI reassessment, on the other hand, is a more comprehensive and structured review of the original RBI assessment. It involves revalidating assumptions, reviewing scope and premises, and evaluating whether the overall risk picture for a unit or site remains valid. Reassessments are conducted less frequently than evergreening and often involve the full RBI team. They are particularly important when cumulative changes, major projects, or shifts in risk criteria may have rendered the original assessment obsolete. Together, evergreening and reassessment provide a balanced approach to RBI maintenance. Evergreening keeps the assessment current on a day-to-day basis, while reassessment ensures long-term validity and alignment with strategic, regulatory, and operational changes. An effective RBI program clearly defines how and when each approach is applied. Evergreening is the process of continuously updating the RBI assessment and its associated inspection and risk management plans as changes occur. It is typically performed on an individual asset or component basis and does not require revisiting the entire unit or site scope. The objective of evergreening is to ensure that new information is promptly incorporated so that risk rankings and inspection plans remain accurate and actionable. Common triggers for evergreening include the completion of inspections, discovery of new damage, equipment repairs or replacements in kind, and minor process changes. For example, when an inspection reveals higher than expected corrosion rates, the RBI assessment should be updated to reflect the revised damage rate, which may lead to shorter inspection intervals or additional mitigation measures. Similarly, after a turnaround where inspections or modifications occur, evergreening allows the RBI database to be updated with actual findings and post-maintenance conditions. Evergreening also plays a critical role in responding to unanticipated damage mechanisms. When unexpected damage is discovered, a focused review is required to assess the impact on risk and determine whether similar equipment may be affected. By enabling timely updates at the equipment level, evergreening helps maintain the credibility and effectiveness of the RBI program without the resource intensity of a full reassessment. Evergreening activities encompass a range of routine updates that reflect real-world changes in equipment condition and operation. One of the most common activities is updating inspection results once an inspection has been completed. This includes revising damage rates, remaining life estimates, and next planned inspection dates based on actual findings. Accurate and timely data entry is essential to ensure that inspection plans remain risk-based rather than calendar-driven. Another key activity involves incorporating new information related to process or equipment changes. This may include operating limit exceedances identified through an Integrity Operating Window (IOW) program, or changes captured through Management of Change (MOC), Process Hazard Analysis (PHA), or similar risk management processes. Prior to turnarounds, evergreening is often used to update risk rankings and inspection plans to support effective planning and resource allocation. Evergreening also includes updating the RBI assessment following turnarounds to reflect completed inspections, repairs, and modifications. By systematically capturing these updates, organizations ensure that the RBI program remains synchronized with plant reality and continues to support informed, risk-based decisions. RBI reassessment is a comprehensive review that examines the full scope and premises of the original RBI assessment. Unlike evergreening, which focuses on incremental updates, reassessment is a structured revalidation of assumptions, methodologies, and risk conclusions. It typically involves the full RBI team and considers the unit or site as a whole. Reassessments are performed at longer intervals and are often driven by significant changes or accumulated minor changes that collectively affect risk. During a reassessment, the team reviews damage mechanisms, inspection effectiveness, consequence models, and risk criteria to confirm that the RBI assessment remains appropriate and defensible. Regulatory requirements, code updates, or changes in software methodology may also necessitate a reassessment. By periodically stepping back and reassessing the entire RBI framework, organizations can ensure that their risk management approach remains robust, consistent, and aligned with current industry practices and operational realities. Several factors can trigger the need for an RBI reassessment. most of which relate to changes that significantly alter risk. Damage mechanisms and inspection activities are common drivers. Many damage mechanisms are time-dependent, and deterioration rates may change as operating conditions evolve. Inspection findings that contradict previous assumptions may indicate the need for a broader review. Process and hardware changes are another major trigger. Equipment modifications, replacements, or bypasses can affect both probability and consequence of failure. Similarly, process changes such as altered chemistry, temperature, or pressure can activate new damage mechanisms or accelerate existing ones. Even when changes are managed through MOC and incorporated via evergreening, a reassessment may be needed to capture cumulative or systemic effects. Other triggers include changes in regulatory requirements, inspection codes, risk criteria, or economic assumptions. When the foundational premises of the RBI assessment change, reassessment ensures that risk evaluations remain valid and defensible. Process and hardware changes can significantly influence both the probability and consequence of failure. Hardware modifications such as changes to vessel internals, piping geometry, or equipment layout may increase corrosion rates, erosion, or other velocity-related damage mechanisms. Relocating equipment closer to ignition sources or occupied areas can increase consequence of failure, even if probability remains unchanged. Process changes are equally influential. Variations in temperature, pressure, flow regime, or stream chemistry can activate damage mechanisms such as chloride stress corrosion cracking, wet H2S cracking, or accelerated corrosion at dew points. These changes may not always be obvious. Particularly when they occur gradually or intermittently, an effective RBI program integrates information from IOW and MOC systems to identify these changes early. While evergreening captures individual updates, reassessment provides an opportunity to evaluate the broader impact of process and hardware changes across the unit, ensuring that risk management strategies remain appropriate and effective. Beyond technical changes, several organizational and external factors can drive the need for RBI reassessment. Changes in population density around a facility can alter consequence modeling and societal risk considerations. Economic factors such as revised repair costs, downtime costs, or production value can also influence consequence calculations and inspection prioritization. Regulatory and standards updates are another important driver. Revisions to safety, environmental, or inspection codes may impose new requirements or expectations that affect RBI assumptions. Similarly, changes in risk criteria within an organization's risk management plan may require re-evaluation of what constitutes acceptable risk. Advancements in RBI software or methodology can also prompt reassessment, particularly when transitioning to higher levels of accuracy or detail. Replacing broad assumptions with more precise data improves confidence in risk results but often requires a structured reassessment to ensure consistency and traceability. RBI reassessments should be conducted after significant changes that may alter the risk profile of equipment or units. Qualified personnel should evaluate major process deviations, changes in damage mechanisms, or shifts in RBI premises to determine whether reassessment is warranted. Even in the absence of major changes, organizations should establish maximum time intervals for reassessment to address the cumulative effect of smaller changes. Industry inspection codes and jurisdictional regulations often provide guidance on reassessment intervals, and these should be reviewed and applied as part of the RBI program. Reassessment is also recommended following the implementation of major risk mitigation strategies to confirm their effectiveness and update risk rankings accordingly. Additionally, reassessment before and after major maintenance turnarounds can enhance planning and ensure that inspection and repair activities are focused on the highest risk equipment. Post-turnaround reassessments help establish a new baseline for future inspection planning. Risk mitigation strategies such as the installation of safety systems, process controls, or material upgrades are intended to reduce risk to acceptable levels. However, their effectiveness should not be assumed without verification. Periodic review of mitigation performance is essential to confirm that intended risk reductions have been achieved. Once a mitigation strategy is implemented and demonstrated to be effective, an RBI reassessment may be performed to update probability and consequence estimates. This ensures that the RBI program accurately reflects current risk and avoids overly conservative inspection plans that no longer provide additional value. By formally incorporating mitigation effectiveness into the RBI assessment, organizations can demonstrate continuous improvement and maintain alignment between risk reduction investments and inspection strategies. Successful updating of an RBI assessment requires recognition that risk is dynamic and changes over time. Organizations must clearly define the basis and triggers for updates, distinguishing between when evergreening is sufficient and when reassessment is required. Understanding and applying these concepts consistently helps maintain the integrity of the RBI program. Strong integration between RBI MOC, inspection, and operating discipline programs is essential. This ensures that relevant changes are identified, communicated, and incorporated into risk assessments in a timely manner. Effective documentation of update processes and reassessment intervals supports transparency, auditability, and regulatory compliance. Ultimately, a successful RBI updating strategy enables proactive risk management, optimized inspection planning, and sustained asset integrity performance, delivering long-term safety, reliability, and economic benefits.